Hi everyone. My name is Imama Ali, and I'm a computer vision engineer and with Neo. And today I will be talking about computer vision for edge devices and its trends and evolution since 2013. Um, so I have so the objective of this presentation would be to understand the growth of computer vision for edge devices and its current trends and the role in hardware and the role of hardware acceleration. Um, so basically, edge computing is processing data near the source of the centralized data centers. So instead of having like a centralized the processing unit, we process the data on the edge device, which sort of is required for sort of some real-time applications um, or basically to help with the privacy of the data. It basically reduces the latency where the device has to upload the data to the center and then receive the output. So the edge computing basically process the data on device and be able to uh, sort of pass the need to communicate with the centralized unit. And then it also helps to reduce the bandwidth cost and it enhances the privacy. So the data is processed on device and destroyed, and there is no need to make copies of data. And it also improves the reliability by processing the data at the spot and be able to sort of see the results very quickly. So the examples for these kind of devices are IoT devices, drones, and autonomous vehicles and smart cameras. And in the past, people used to basically use handcrafted features like histogram of gradients or SIFT for object detection and use Haar cascade classifiers. There was work from seminal work from Boiler Jones, which people used for a long time. And until 2013, people started uh, testing deep learning to do these computer vision based tasks. And by 2016, people started adapting deep learning on edge devices as well. The classical methods were limited by the accuracy, and the deep learning based models sort of boosted the accuracy. So people started adapting those very quickly. And the specialized the deep learning models needed like specialized hardware to sort of run in real time. And a lot of companies offered their solution like Qualcomm, NVIDIA, and Google, and they started to deploy these models on the specialized hardware for efficient performance. And at this point, people are using a lot of these devices on edge for computing. And for the future, basically, the shift is towards transformer-based models. So be able to build hardware which can accelerate transformer-based models. And on-device, not just inference, but on-device learning is also is also becoming important. Um, the key challenges for edge devices is basically they are constrained with memory and power and computational limits, and they mostly these applications require real-time processing, and the model deployment is basically it needs a lot of accuracy and efficiency. And also the data privacy is important as well, which the edge-based devices are good at. Um, the current trends for edge devices is that people are using transformer-based networks for high accuracy, and they are computationally intensive. And there is a need to optimize the transformer-based networks to deploy on edge. Some of the versions are already available, like mobile VIT, but they are only good for specific tasks. So for a wide range of other tasks, there needs to be other models which can be deployed on edge. Um, and Companies are developing good hardware very quickly to deploy the transformer-based models, like tensor processing units from Google and neural processing units from NVIDIA. And also people are using different other techniques to compress these models, like sparse, like pruning and quantization. So what happens is that a lot of weights do not contribute during the inference time. So people do pruning to get rid of those weights and make the size of the model smaller. And also, the edge-based devices are basically optimized for fixed point computation. So if you can quantize your model to do computations in fixed point, it will run much faster. And different devices have different kind of fixed point operations. So you can quantize your model to run on that particular device. Also, distillation is a technique which people use a lot for compressing the model. So you can use a teacher network to train your student network, which is much smaller in size, and use that for deployment. So these are different techniques people use to reduce the size of the model and make the inference faster. And also, there's a trend of federated learning where you learn on device and keep on updating the model weights. So basically, it's an online learning loop where you where you don't have a lot of data, and you can use newly acquired data to update the weights of your model. Or if your model is accuracy is not as good, you can use the newly acquired data to update the weights of the model, and do it on the device, and use the newer model for further inference. Um, with regards to the hardware evolution for these models, earlier people were just using GPUs. Now people are using more specialized hardware like TPUs and Jetson modules, and ARM-based architecture, and other NPUs to accelerate the compute. People are also using customized ASICs and FPGAs to deploy the transformer networks. Currently, people are developing transformer workloads, optimizing hardware for transformer workloads, and also focused on the energy efficiency and the throughput for these hardwares. Um, so, uh, some there these are some of the areas which uses edge computing for different applications. So these are drones, autonomous vehicles, and smartphones, and also sort of gaming consoles, which uses edge-based devices for the VR or the AR applications. Um, and and mostly these uh, sort of so these are some of the areas. Next is the software frameworks that are used for edge deployment. There are a lot of software frameworks. The most prominent ones are NVIDIA TensorRT and PyTorch Mobile. NVIDIA TensorRT has the highest performance among all the software frameworks that are available, and people use ONNX runtime and TensorFlow Lite for a standard model representation. Um, NVIDIA TensorRT has the best performance on NVIDIA hardware and other hardwares as well. And with transformer and hardware acceleration, basically transformer networks are very huge compared to convolutional networks. So there's a high memory and computational requirements, and there's a sequential processing bottleneck. So people try to deploy these networks on different resources in parallel and be able to get rid of the performance bottleneck. Um, so there is a push to be able to use like different cores for different for at different for different for data at different sequences in the model. And also, there are hardware specific optimizations with regards to VIT, and there are lightweight transformer models as well. So there are a few energy efficiency techniques that people use that I've talked before, which is model compression, using pruning and quantization, and there are dynamic inference where you can sort of stop the inference at a certain point and use that as a result. And also conditional computation where you can use certain conditions for the computations and you don't use the whole model for the prediction, and use the conditions to optimize the computation. There are a few efficient architectures which people use as like the foundational models, like MobileNet VIT and efficient net, and fine-tune these models for any downstream task. Uh, and as I mentioned before, people are also using federated learning, which is learning on device. And it basically updates the model weights on device and use it towards the next inferences. And it helps to improve the privacy and also reduce the communication overhead. And the applications are basically fitness trackers, or there are some privacy preserving analytics that require federated learning. Um, the future directions for these architectures are basically uh, combining the vision models with language and audio on edge devices and be able to create like a multimodal network which can process all these different modalities, um, and uh, uh, be deployed on a low resource sort of environment. Also, real-time adaptation. These devices have to sort of run and sort of infer in real time. And also, uh, it can use different energy resources from the environment to gather energy and not use the batteries. So these are few of the future trends that are coming up in edge devices. And the key takeaways are basically that it is the edge, basically when people have a good model which has high accuracy uh, in in a centralized sort of environment with high compute, people try to sort of compress that model and use it for and deploy it on edge devices for more real-time sort of applications. And people are now deploying transformers on edge, and hardware acceleration is the key to sort of unlock all these applications. So there are newer hardwares coming out which have higher throughput and compute to run these models. That's all. And if you have any questions, you can let me know. All right. Thank you.